Hey everybody, it's Marty the JavaScript Party, and I'm doing a quick 3JS video, and this one is a tubular, totally tubular, bro, and it's really cool. And let's just rotate around the x-axis for a second. Woohoo! Look at that bad boy. And then let's rotate around the y-axis, and that's just the y-axis for us. You know what I'm saying? Like it's the y-axis in the group. So that's why, like, I think if all we were doing is a shape, I think the y-axis would be like spinning it, but I don't know. I'm not sure. Um, it is confusing because, like, okay, so if we reload and we rotate around the y-axis, see that makes sense, right? Because it's rotating around the y-axis. But as we rotate around the x-axis, you would think that the y-axis would be the other direction. But anyways, that's so cool, I think. Really happy with that. Um, Now the code is pretty interesting. I'm just gonna Alt tab over to the code. You see what you do. So we have our get to mesh. I think this is literally, I think this, what did I do in SD? Oh, okay, I actually just removed some white space, it looks like. Or maybe I added it. No, it looks like I removed line 11, which was a white space. All right, so we created tube mesh and we created a new function called getTube, and then we add the tube mesh. And so we have the push tube mesh. Now it would be nice if we had like that Z. Remember we had that animation where like you could make the camera go in and out. It'd been nice if that was in here. I remember I think when we create the animation we pass in the camera when we want to do that, and then we change the camera like by one position or something every second. But so things to keep in mind. Oh, let's go look at the get. This is actually the most important thing. All right, so get to mesh, basically create our material as per usual. Then we create a points in space, and then it will this using this cat mole run curve, and then we use this geometry, and this will then make a tube that goes from point A to point B. So like, I guess theoretically we could make another one here that goes like to 0, 3, and then 3 on the X, right? So basically it's 3 on the Y, 3 on the X, and let's see what we get. So I think that makes sense. And then let's try a little more narrow radius though, like a radius of 1. See if that looks different. Yeah, that's nice. Now let's make another curve that goes straight down, right? So it's 3 on along the X, but 0 along the Y and 0 along the Z. Oh yeah, and then let's just make one last curve. Let's just close it out. So, I mean, depending on what you're doing, this could be very, very useful to you. So that is so interesting. So let's try this. Let's rotate along the Y. So I don't know what we'd have to do to get it to like curve completely, like so that it's connected. I would imagine we probably need one more that goes there, and then that'll sort of mimic. So now we're back over. So now we have like two curves, but they go over the exact same spot, so it shouldn't matter. Yeah, there we go. I think that's what we're looking for. Now there is a weird crease here, and I guess that's the, Yeah, that's where we did the double. I wonder if we change the segments. So let's change this to like 64 segments. No, that didn't help at all. Wonder, I wonder why we have this extra double curve here. So I'm guessing we would not want that. But I don't know. I don't know how that works. Because it goes 0, 0, 3, 0, 0, 0, 0, 3. And then, yeah, for some reason it decided it needed an extra sort of segment there or something. I don't know what that is. Let's rotate it along the Y just for a second. Yeah, see, we got this line here, which to me doesn't make any sense, like why we have this line here. Wonder if we make this one, instead of all the way to 3 vertically, if we make it 1. So it's not like as far up. Okay, so now it's, oh, how weird. Look at that. We got like an extra thing there. I don't know. I don't know exactly what you would have to do to get it to match all the way around, but say 0.1. What if we do a 0.1? So now we just have a little weird little artifact right there. Curious, what if we make it like 5? That's pretty cool. It's like the letter B. Yeah, I guess you could make like little letters of all these things. But yeah, I don't know. I don't know exactly what you'd have to do to get like the curve to look right. But let's go back to our original tube. Now, I wonder if there's any other things you can pass into tube geometry or tube mesh geometry. Wait, where does that curve? Oh, okay, curve. Yeah, what you could pass in here, like if it could be other kinds of curves. Uh, a 3D parameter that inherits from 3 curve base class. Okay, so there are other kinds of curves, so it wouldn't be surprised if one of the other curves handles that specific situation better. I'd imagine, like all these things, it's like you could just get rabbit holed into every one of them. Um, but for now, I think we'll just sort of leave it here. Let's see. But that is awesome, I think. Definitely like feels like maybe this could be used like if you put it the right things, it could look kind of like a black hole. I wonder, let me ask ChatGPT if it has any thoughts on that. Could you use the tube geometry with star-like like photos with a star-like photo? It should be image, probably not photo. Image um, to create a black hole effect. That's one of the those ideas where tube is a great building block, even though it isn't a whole solution. Option 1, spiral tube, my favorite. Instead of a straight line, make the path a spiral that narrows as it approaches the center. Okay, what is this? Imagine 50 to 100 tubes. Animate either moving along the tube or How do you do a spiral? Dark sphere in the middle. 100 thin tubes. Geometry spiraling, converging on its small glowing particles. See, like once we get um how do you do it? How do you do a spiral? Um okay, so something like this, where our points. Okay, so we're creating these points, and these are, I guess these are our vectors. Yeah, this is where we create our vectors based on this, and then it's going to create how many how many vectors is this thing going to create? Let t, well, it's less than math pi times 8. It's going to make, and then t is only increasing by 0.1, so it is just going to make a um it's just going to make a like thousands of these things. I have no idea if this will be that. But maybe that's what I'll do tomorrow. That's probably what I'll do tomorrow is this spiral um, function. But anyways, for now, I think this is in fact awesome blossom. I'm really, really impressed. 3GS just never ceases to impress me. I guess that's one of the real side benefits of this project of choosing 3GS as my sort of like API that I just really wanted to get like fully just deeply involved or deeply absorbed into, and man, it just the fact that it's just constantly delighting me is just wonderful. Always happy coding, everybody. Have a wonderful day. Bye.